So, and again, you all can use these too. All right, say hey, Katie. Katie. All right. Okay, so nothing brand new today, but we're going to use what we've already done to do a couple other tasks with it. So this, first of all, is just kind of just a review of what we've done, right, of the steps. So when you're given f of x, again, you want to identify the domain of f of x, which means like find any x values that may not be available, right? So like, for example, if we had something like this, you know, we know x cannot equal 3. So just kind of make note of that, okay? Then we find the derivative, then we find the critical points, the x value where the derivative equals 0, and x value where the denominator equals 0. But check it with this value, right? Because if it's the same, it's not a critical value. Okay. And then we plot the critical values on the number line. We determine increasing or decreasing. We determine a min or a max for each point. And we plug into the original equation again to find relative min or max. Okay, so that's just kind of a summary of the steps we've looked at so far. Now what we're going to do today, a couple different things. We're going to do some application problems, but I'm going to come back to those. So we're going to skip the next 2 slides for now and go right to using that information to sketch a graph, okay? Because this kind of follows along with your homework a little bit more. All right, so if we looked at homework number 15, we found, and I've still got the homework problems up, we found that on homework number 15, we found a min at -12, at -1, of -12, and a max at -3 of -8. Okay, so we're going to use that information and just sketch a graph of it. So I'm going to do this. Sorry about that, didn't put those lines on yours. Okay, so, and again, you'll have to, the add and the of belong to the right numbers. I just kind of did them in different orders, you know, which is fine. But so now we know that we have a max of -8 at -3. So we could provide some x values here and some y values. Okay. And we can sketch the graph just knowing the min and the max, right? So if we have a max of 8 at -3, that really means the point -3, -8. Everybody agree with that? And we know we have a min at -1 of -12. Tells us that point. So we could go ahead and plot that. So at -3, 1, 2, 3, 4, 5, 6, 7, 8. So we've got a point here. So that's -8. And then 9, 10, and this is -12. And we also have a point at -1 of -12. And then just to help make a better graph, what's another point we could plot pretty easily on this? What's another number we could choose that if we plugged in, we could find a value pretty quick? 0. What happens if we plug in a 0? -8. So if it's available, you always want to try to use your y-intercept. Now, a lot of times your y-intercept is actually going to end up being one of your critical numbers, okay? But in this case, x equals 0, we get -8. So that's another point we can put down. Okay? And if you look back at your homework, then we know that you had this little number line, right? And if you found that there was a max happening at -3, then you found that it was increasing, then decreasing, then increasing, right? So we can actually sketch this graph just using what we know here and our points and connecting the dots, right? So we know it's increasing on the way to that max, and then decreasing, and then increasing again. So we can sketch the graph. Make sense? So your min and your max give you some points, and then your number line tells you the direction, you know, your function should be moving. Okay? So what I want you guys to do is I want you to go ahead on these next two and go ahead and find, so treat it just like a homework, like your homework, and go ahead and find the mins and the maxes, and we're going to try to sketch this graph. Okay, so I'm going to turn off this. Okay, so if you did that one, again, you're plugging it in, you got your critical numbers of -2, 0, and 2, and that tells you, and then you find out whether they're increasing or decreasing by choosing values. So we find it's increasing, so we have a min, then it's, decreasing, then we have a min, increasing, then we have a max, etc. So then you plug those values from your critical numbers into the original equation to plot your points. And then how you connect your points is based on whether it's increasing or decreasing. So this was decreasing at first, so we're coming down into this point, then increasing, then decreasing, then increasing. Okay, now you guys finish up the next one. Oh. Okay, so let's take a look at these. So again, this one was a little bit easier. So you took the derivative, you got 3x squared plus 6x. Again, take out GCF, it's a 3x. So yeah, a couple of you have learned already. You've got to factor it carefully, because if you mess up here, then all the work you've done is based on the wrong numbers, right? So take out a 3x, we get 0 and -2. So those are our critical numbers. Yeah, Maddie, do you have a question? No, go ahead. And then we pick values in that interval to see if it's increasing or decreasing. So we know increasing, decreasing, then increasing. So a max and a min. Plug it into original function to find out exactly where. So we know we have add -2 is +5, add 0 is 1. Now to figure out how to connect those dots, we look back in here, or connect those points. And it says it's supposed to be increasing, coming up to -2. So increasing, then decreasing between -2 and 0, and then increasing past 0. So we get that. Make sense? Any questions? Okay, awesome. All right, so that is sketching a graph. So part of your homework is just 16 and 19 from the homework we just checked. So 19, did you all have to do 19? Okay, so 19, half the work was already done. Oh, no, you didn't. Okay, so sorry about that. So it's the same page of homework that we just checked, but it's, so just choose those two problems, okay, and do what we just did. Okay, so everybody pay attention. Don't do just what it's asked you for on directions. You're actually going to find the relative mins or maxes, but then you're actually going to sketch the graph, just like we just did. Okay, so other than that, I mean, it's just like homework from last night, only you want to end up with a graph like this. All right, everybody clear on about that? Okay. All right, only other thing we're going to do today is we're going to look at using, solving a couple just word problems based on finding max and mins. Okay, so everybody go back 2 pages now. Very good. Okay, so it says company, and these actually go pretty quickly. So a company has a profit function of this. where X is the number of units sold, how many units should be sold to maximize profit? What is the maximum profit? So if we want to find out how to maximize profit, it's really just trying to find max extrema, right? So how can we, if we have a profit equation, what can we do? Take the derivative, find critical points, and find which ones are max, which ones are mins, right? Okay, so let's try it. So first we're going to take the derivative of the profit equation. So we get negative 3x squared. I'm taking the derivative of this, plus 36x minus 96. Now I need, so nothing's, I can't exclude any numbers from the domain, right? So I need some critical numbers. So my critical numbers now are going to be possible answers to the question, right? Because if I find out a unit that makes a relative max, that's going to be my max profit. So how can I factor that? Take out 3 out, and I'm going to go ahead, I'm going to take out a negative 3 like we talked about earlier. I like to have positive values to factor. So if I take out a negative 3, I get x squared minus 12x plus 32, thank you. Okay, and now I need to factor that. So what multiplies to 32 as to negative 12? Negative 8, negative 4. So my relative mins and maxes are 8, or my critical numbers, so my possible mins and maxes are going to be 4 and 8. Do I need to worry about 0 since I took out the negative 3? No, right, because there's no variable there, okay? So my possible critical numbers are 4 and 8. And now I want to find out which one's a max, right? So which one represents a relative max? So I plug in, so let's see, I'll choose, what, 3 maybe? In the first interval, and I plug it into here. So again, don't forget this negative 3. So when I plug that in, I'm going to have a negative number for that. 3 minus 8 is going to give me another negative number. And 3 minus 4 is going to give me another negative number. So this is going to be negative. I can choose 5 for the next interval. I've got a negative 3, so that's going to be negative. 5 minus 8 is going to be negative. But 5 minus 4 is going to be positive. So I'm increasing. Everybody with me? I can choose 9 for the next one. So again, I've got the negative 3, I've got a negative. 9 minus 8 gives me a positive, and 9 minus 4 gives me a positive. So this is negative. So what represents a relative max? This is going down, then up, then down. So the 8. Does that make sense? So how many units should be sold to maximize profit? It's going to be how many units? 8 units. And then what is the maximum profit? So if 8 is going to be where the maximum profit's happening, how do I find out what would be the maximum profit? Plug it into the original, right? So I want to find P of 8. So I get negative 8 cubed plus 18, 8 squared minus 96 times 8 plus 1,000. Everybody go and print that. I'm going to do it on here. It takes me so long on the smartboard. So negative 8 to the third plus 18, 8 squared times 26 times 8. What did you guys get? 872. Awesome. So when we sell 8 units, we make a profit of 872. And we know, again, we don't have to graph it, but we know that 8 is the max that function ever hits. Okay? Are you good with that one? Again, these are pretty simple when it gets to the math parts of these, although this one mixes up a little bit. So a bicycle company has the following cost and demand functions. So here's your cost, and the demand function is actually giving you a what? What's this little P stand for? Not profit, price. Remember, little demand functions often give you the price. And P is the price per bicycle. So find the number of units, Q, that produces the maximum profit. So do we have a profit equation here yet? No, we have demand and cost. How do we make it a profit equation? What's profit? Profit is how much you bring in. So it's going to be revenue, how much you bring in, minus how much it costs to make it. Do we have C of Q? Yeah. Do we have R of Q? No. How do we get R of Q? Times what by Q? Right, we times the demand. So the demand equation represents price. Revenue is always whatever your price is times your quantity, right? So yeah, this is not going away. I know you all wish it was. So first we have to find our revenue equation. So we're just going to take our price equation and multiply it by Q. So we get 90 Q minus 0.02 Q squared. Now to find the profit, we want to do what? Right, so now we want to take this 90Q minus 0.02Q squared and subtract our cost equation from that. So minus 25Q plus, is that 5,000 or 500? 5,000. Okay, so again, we're trying to build our profit equation. Thank you. Okay, so I'm not ready for that yet at all. So again, we'll get done with this after lunch, but let's try to get it at least to our profit equation. So what can we combine? 90 minus 25 is 65Q. Nothing combines with the negative 0.02Q squared, right? And then we get a negative 5,000. Everybody agree with that? Because we have to distribute that negative. So that's our profit equation, right? So to find maximum profit, we're going to have to do what? Take the derivative, right? So actually, let's go and take the derivative. Yeah, that probably would be a good idea. So we get negative 0.02Q squared plus 65Q minus 5,000. So we take the derivative of that, and we get negative 0.04Q plus 65 Yeah, so that's not bad. And then we set that equal to 0. That makes sense? And how do we solve that? So actually, all we have to solve for now is this 1q to the first. So how can we solve that? Minus 65. So we get negative 0.04q equals negative 65. And we do what? Divide by negative 0.04. And we get 1625. So since we only got the one critical point, so we're only finding a critical point at 1625. So actually after lunch, we'll verify that that's a max, okay? And then that'll be our answer. Okay, so we're going to check this. So it's always good when you're saying you found the maximum units, it's always good to make sure it's a max. So we want to, so even though we only found one critical point, we want to make sure it's a maximum. So we have to choose a number less than 1625. And we could choose any number, so we could choose 0. So if you put 0 into this derivative, negative 0.04 times 0 would be 0 plus 65. So we'd have, so it's increasing, coming up to 65. So we know that the derivative at 0 is positive. If we found the derivative at, let's just say 2,000, right? Because we have to choose a value greater than 1625. So the derivative at 2,000, again, here you really have to plug it in because you have to make sure that 2,000 times 0.0 times negative 0.04. So let's 2,000, I'm going to do this on my own calculator, times negative 0.04 is negative 80 plus 65, so it's negative. Okay, so yeah, 1625 represents a max. So our max profit is going to be at 1625 units. Kendall. Yes. So yes. So this said find the, well. So right now it's to find the number of units Q that produces the maximum profits. So 1625 is that answer, is the number of units that produces the maximum profit. So now to find the actual maximum profit, what are we going to do? So we just confirmed that by selling 1,625 units, it is a max, right? And so that's how many units we have to sell to make the most profit. Now we have to, what do we do with 1,625 to find how much money we actually make? Plug it into what? We've got lots of equations. Plug it into the original profit equation. Yes, because again, remember, we had, so yeah, just to recap, since we just got back from lunch, we used our price equation, multiplied it by Q to make that a revenue equation. Then we subtracted the revenue minus the cost to give us a profit equation, right? And that's the one that we manipulated, right, to find the maximum units. So then to actually answer the question about how much money we can make selling 1,625 units, we plug it into this one. So negative 0.2 1625 squared plus 65 times 1625 minus 5,000. Oh yeah, thank you, 0.02. So negative 0.02 1625 squared plus 65 1625 plus 5,000 or minus 5,000. 47,812. Did I get that with me? Did anybody try it and not get the? All right, y'all are trusting me here. Let me make sure. -25. Okay. I think I can pull up the notes from last year, but that does sound familiar. So 47,000. What's that? Did you get that? Okay. Okay. So again, the max to make the most profit, we sell 1,625 units, and then how much we'll make by selling those will be $47,000 profit. Right. So that's the Y value. Yeah. So like if our profit equation, is going like this, whatever, we're finding this point right there. Okay. Okay. So again, that's it for today. Let me. Yeah, so the rest of your notes we're going to go over next class. I didn't get that far with A block the other day either. So, but for homework, I want you to do 16 and 19. I want you to sketch the graphs, and I'm going to give you a sheet of paper where you want to do 8 and 9.